Welcome to week number 2. We're using the same map document as before. I've just saved it as week number 2 to track our progress here. So we're looking at my 95 stream temperature locations and the number of hours that they spent over the threshold of 70 degrees Fahrenheit. We're also looking at the main township boundaries and the 10-meter resolution digital elevation model and lakes and ponds. So what I'm going to be asking the computer to do is select those points that meet certain criteria that I set. That's called a query or a select by attributes query. I'm going to right click and open the attribute table and click on this tool here, select features using an expression. We can use this attribute table to manually select those features that meet certain criteria. We can sort the attribute table by clicking here, first from smallest to largest values, and then largest to smallest. If I say I want everything over 0 degrees, so non-zero number of hours above 70 degrees Fahrenheit, I can click here, hold, drag up, and then release, and that selects in yellow each one of these points that meets that criterion. That's all well and good to do manually. It's not very repeatable, and it's not best practice, but you can do it. Then I can hit this deselect features, and that selection goes away. Now, I want to be able to do that in a repeatable way, and I want to be able to write more complex queries. So this is not the most user-friendly interface, but once you get started, it starts to make more sense. So follow along here. Let's try typing in this attribute field header here. So hours above 70 degrees in July and August. Hours, oh, and there it is, that selection. I can double click on that and that adds it to my expression. And I want to find those features where that value is greater than 0. So this is the greater than symbol, and that's just by the question mark on your keyboard there. So hours above 70 degrees greater than 0. And now select features. And here's all those. So if it's 0, it doesn't get selected, but if that value is greater than 0, this expression is true and it gets selected. Now that was a fairly simple query. We want anything where this number, this field, is greater than 0. It's true for these features. They're selected. Now what if we want to say, all right, we want to select those where it's greater than 0, but only if it's also greater than 64 here. So the average daily maximum temperature has got to be greater than 64, and it's got to have a non-zero number of hours over the 70-degree threshold. That is an AND statement. So AND, start typing in average daily max here, the title of this column. Double-click complete, greater than 64. So then select features and see how it's deselected those where this field is less than 64. So this spent more than 15 hours, or spent exactly 15 hours, above the threshold of 70 degrees Fahrenheit. But the average high temperature throughout the summer months was only 63 degrees. So that's falling out of this selection. It is not true that both of these criteria are met. Only one of them is, and that's not enough to satisfy this equation. So when you're looking at this, it's asking, with an AND statement, are both of these true? The opposite of that is an OR statement. So if we type in an OR here instead of an AND, let's see what happens. Select features. So all of these, the statement is true. It is greater than 0 in this field. But it would also be satisfied if this field was greater than 64. And there's one there. So we have one here, Baker branch number 2. Where it didn't spend any time at all above that threshold of 70 degrees Fahrenheit, but the average daily temperature, or the average daily high, was greater than 64. Very interesting. I can, if I choose to go look at that one in particular, I can hit this button here, clear selected features, select that one there. Let's move this out of the way. What is going on at this Baker 2? Very interesting to see that. But let's not get distracted from our queries here. So clear selection, go back to select using an expression, And let's talk about queries that involve words. When I'm writing a query with a field that just involves numbers, I can use mathematical operators. When I'm writing a query that involves text, I have to use a different set of operators. The most common of these is like. Let's demonstrate what that looks like. So I'm going to start typing in notes 1. That's my field of notes I took in the field, and these all have to do with whether or not I liked where the sensor was placed. And if I say the sensor is not placed well, then that's not going to be very useful data, is it? So I'm going to type in notes 1, like, single quotes, good, and then a percentage sign. That percentage sign is a wildcard. So this is going to select anything that starts with good and then anything after it. I don't care what it says after good, I just want anything that says, Neil said in the field it was good, it ought to be good. Select features. And there's everything that starts with good. Now do we see a problem here? Sometimes fieldwork Neil didn't write good. Sometimes fieldwork Neil wrote excellent. Feeling enthusiastic that day. Great. So there we can use an or statement again, not an and, an or. So notes 1, like, single quotes, excellent. End with percentage sign wildcard and select features. So now my good and my excellent are both selected. Now I just have to look through these other notes and say, oh, bad location, buried in sediment, beaver dam, not a good location on a split channel here, moved 100 yards upstream, okay, but move next year, okay, but the stream channel moved a bit over the course of the year. Stream placement good. Oh boy, who was taking these notes? Well, that was me because I didn't have anybody else taking my notes. So now I get to use another or statement and show you one more thing. So or, notes 1, like, open quotes, start with a wildcard, good. End with that, same percentage sign, end quotes, select features. But nothing happens. Why? This is case sensitive. If you want to make it not case sensitive, you can type in an I before like, and then try select features. There it is. So that's something to watch out for. If you want case sensitivity, that's the default like. If you don't want case sensitivity, you have to type in an I like. And why couldn't I just type in without a percentage sign? Select features, that goes away, because there's something else before it. There's these other characters, the space, the stream placement, so I have to give it a wildcard on both sides for that to be selected. Now what we can see here is we've created an expression, and we can save that expression here and call that good stuff and save that there. But what I like to do is copy all this. So select, copy, and then paste that into Notepad. And that, I can create a little text document of my code that says, if I want to copy that back in, I can close this, it goes away. I can then open up the expression builder again, copy that text, paste it in there, and let's just demonstrate to you that it still works. Boom, there it is. So I've saved that set of instructions to ask the computer, find me anything that starts with good, or starts with excellent, or has good somewhere in it. And we can see even one more thing. This one is well placed, but not well anchored. So I had to correct something about how I placed that sensor, but the where was good. So the where is enough to qualify this for one more or statement. Or notes 1, like, well, wildcard, end quotes, select features. Now I've got all the data that I'm really confident in. These ones here, only partially submerged, might have an issue with whether it read well or not. Flow barely a trickle, so there's not even enough water on this to call this a water temperature sensor. There's issues in here. This is the whole data set, and we have to find the ones that are good. If we want to then work with those data, what can we do? we have these selected. We can zoom out and look at them. Let's go ahead and close that. These are all the data points that I consider to be good. So let's go ahead and do something with them. If I want to buffer this data layer, I can go Vector, Geoprocessing Tools, Buffer, and use Selected Features Only. That's a powerful tool. You don't have to export new data. But let's close that and say I only want to work with these data in the future. I don't want to worry about the rest of these. I don't consider them to be good. Let's go ahead and export these data so I have a new data set that only contains those data points I have a high confidence in. Right-click, Export, Save Feature As, and Save Only Selected Features. We'll give it a name, and we'll call that, well, let's pop that back to GIS 300. Let's make week 2, and we'll call that the Good Stream Sensor Points 2019. Save. And now, when I pop that in, now I only have those data points that I have a high confidence in. These ones have some other issues, and if I want to know what those issues might have been, I can use this Identify Features tool and click on them. And it's not working. Why? I need to either click on that so it's selected, or I can do a right click and it gives me the option to ask which one do I want to identify. I would like to identify from stream points, thank you very much. So let's see, wild stream was retrieved, okay location, but sediment may have moved channel to river left. So maybe I did want that in there in the first place. That's unfortunate. Let's see how we can deal with that. That's as good a time as any to learn how to copy and paste a feature from one layer to another layer. So we've identified this feature, wild stream, and turns out it's okay. The placement next year ought to be different, but for right now we can include that in the data set. So I'm going to change this from an identify to a selection. There's wild stream. I'm going to select it. It doesn't like to select because that's not selected here. So I have to click on that. Now we're pointing the selection tool at that layer. Click, hold, drag a box. It's turned yellow. It's selected. Now I can say Edit, Copy Features. And now I have to do one more step here. There's sort of a safety mechanism where I have to toggle the editing. Right-click, Toggle Editing. Now this feature or this layer is editable. Before it was not. I couldn't paste things to it. I couldn't change the data. It was in a safe condition. So now I can say Edit, Paste Features. And now I can clear that selection, and now see I've got this green dot here. All the information to do with wild stream is now included here in Good Stream Sensor Points 2019. If I open the attribute table, I can scroll. Where's that name? I can sort by alphabetical order. There's wilds with this OK location. We're good to go. Problem solved. Let's go ahead and check the rest of these. So using the selection or the Identify Features tool, click on there. See, it doesn't like that. I can right click and say, tell me about this stream sensor point. Bad location, lodged high by a stick, check data closely. So that's a good call. I don't want to do that. Let's go ahead and click on that. So it's selected. I can just left click. 100 yards upstream, unmarked anchor, poor location on top of what? On top of gravel bars. So we don't trust that one. Let's take a look here. Location marked blue, not in deepest part of the stream, covered but risky, move. So that's one I wanted to move next year. It is still receiving water. Let's just make a judgment call and leave that one out. Sensor is submerged, but flow notably less than in spring. May be dry in a drier year. There's nothing wrong with that. Why did I do that? So let's go ahead and select that one. Select, Edit, Copy Features, point it at that one, Edit, Paste Features. There it is. So now that's in there. Let's carry on with our checking. So we're going sort of northeast to southwest here. So let's check that one. And again, we have to select the one we want to see. Oh, let's see, compromised by beaver, end of story. Nothing down here. Let's see, here's one. Only partially submerged, no good. And let's see, what else do we have? Flow barely a trickle. Sensor still below water, but likely to be dry in a drier year. Rock anchor retained. We can keep that one. So let's go ahead and select that, edit, copy features, point it where we're looking here, edit, paste features. And now that's where it belongs. Back to our checking here. And again, we don't like to be pointed at if we're not selected. Buried in sediment. Suspect some movement of branches. Strip cut to stream side. So there was some sort of a harvest that came down close to the stream there, and it was buried in sediment, so I don't trust that data. Not ideal location. On split channel, but anchor is firm. Should be acceptable regarding temperature. So my judgment looking at that at the time was it's good to go. That didn't get caught in our initial query, so let's go ahead and select that. And again, edit, copy features, edit, paste features. So now that's where it belongs, and all of these ones that we have here, these are the ones that we consider to be really untrustworthy. I think I might have missed one here, so let's identify that. And again, new beaver dam constructed. Yeah, we don't like beavers affecting our data. 100 yards upstream, poor location. All right, so now I trust that, and we have all of our data together. Let's save the layer edits, and then let's toggle the editing so that's locked in and safe. Clear all of our selections and see how many points we actually have that are good. So let's open the attribute table. And we have 85. So it looks like 10 were somehow compromised, not terrible. So about 12 to 15% of that was lost to some issues with data quality. But we still have 85 stream sensor points, which are good to go for further analysis. Before we finish, one last note about copying and pasting. These two data sets are completely similar in their format. Everything about them is the same because I just created this by exporting from that. If I look at the attribute tables, this has the water ID, air ID, northing, easting, and they're all in the same order. If I changed these around, if I renamed these, if I added new attributes like the width of the stream, the area draining to the stream, that kind of a thing, those things wouldn't magically appear in the new data set if I was copying and pasting. I'd have to recalculate that, redo that, change the fields around. Copying and pasting works great when you have two data layers that match, but if they don't match, you're going to have other issues getting them to come together. All right, now we have our 85 good stream sensor points, and we can uncheck our old ones. Let's go over again how to display this by an attribute. So let's double click here, and we want to have a graduated symbol base here. And we want to use the value, let's today use the average daily maximum temperature, and classify. And I want to have pretty breaks. So mode, pretty breaks. So from 52 to 55, and then breaks of 5 up to this maximum of 75 to 77.7. Let's go ahead and apply that, make sure we like it. Not quite as clear as I like it. I'd like this to be a bit bigger. So let's see, if I click here, I can change the size, make that size 3. Apply. That makes all the points bigger, all that easier to see for you. Okay. And now we can see by turning these back on and off which data points we lost. And that's unfortunate, but the way it goes.